So hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 161, and in this video we want to test a little bit our knowledge about classes because like I all time say, understanding declarations, definitions, and so it's easier than to use them. That means if you already understand that declarations means not automatically that you can use this also automatically in a project, and that's why we need to practice a little bit. But if you think that what we did so far, which is not much because class has so many more things and will become a little bit more difficult, but if you think that what we did so far is easy and yeah, very easy to understand and you can handle it, then you have here and now the chance to prove it. Because we want to make here a fast little exercise. Of course, we will learn also some new things as well while we're doing this exercise. But in this exercise, I want you that you create, similar like me, a lamp class. But this time I want that you simulate this lamp. Simulate means here we have now this object lamp like in our real world. Right? We have in our real, for example, my house lamp or my flat lamp or whatever. And I want that you make one more class, which is a switch. And the switch should turn on off the lamp. And later, I want that you show the state of the lamp if it's on or off. But important is that you have turned on off the switch as a person. So this is this little exercise, and if you say this thing what we learned so far is easy, then you should be able to do this. And of course there are many different kind of solution. There is not one perfect solution, and like all time, if you try to do it and it's not perfect or it has many errors, no problem, that is a way to learn it. But just try it and see if you can do it. So again, one more thing, if you define a new class, try to define this new class above the other class or below, depends. If you want to use the class properties in this class here. And I will show you this in a moment, but before that, let me say one more thing about the simulation things. This class here, like I said, is all time an object in our real world, for example. Not necessarily, but could be. And in this case, it is a lamp. For example, like I said, it's my flat lamp. So when I enter my room, for example, and then I can see that the lamp is on or off. And this is the first simulation thing. So I, the person, enter the room, I see the lamp is on off. Then if it's off and it is dark, then I go to the switch and I use the switch to turn on the lamp because it's dark, I want light. Then I put the switch and I turn on the lamp. And then I want that the switch tells the lamp you should go on. Yeah, turn on, so make light, right? And then as a person, I can see that the lamp is now on because my room is enlightened, or what is called headlight now. So anyway, that is the simulation what I want realize with a class. And the first class I have here already, very bad made. We have not many things in it. And the second class you should make here a switch, which is trying to simulate this behavior. And like I said, this behavior, this simulation behavior, we will program actually here in our main. So not in the class, because the class itself is one part of the simulation, which is providing us the object. For example, you create this lamp class, you provide the objects for the lamp. It has a lamp name, voltage. In my case, I changed here a little bit and said here the lamp has a state. A state means just situation. In this lamp is the lamp on or off? The situation at start, I said you are off because I enter my room, and then I want to turn it on, for example, if it's dark. If it's not dark, then I turn it not on. And for this one, I need also a functionality for example, lamp turn on off. And yeah, and you should do this, you should pause the video and try it on your own. But of course we continue and I try to do this as well. So, but before I go on, last fast recap what we did so far. We made a class. This class I put here in a namespace. I put it just in a namespace that I have no name conflicts, and it is similar to this one which we already know, this std. This is the standard namespace. And then, you know, the string, for example, my name, and then yes, and then I assigned it all times something like this one. And you can see that what we have here is similar. Now I have called this namespace electrician, just for a fast recap before I start the simulation. I mean to, yes, the creation of this class. And then I create this lamp, and you can see I could have to give it just like here before a name. In my case, it's my coder's lamp, because let's say I'm this coder here, then I call this coder's lamp. Coder's lamp, for example. And we learned in the other tutorials already that this one here is calling the default constructor if it's provided, or if it's not provided, then it's calling an implicit constructor. What means this again? We have a constructor section here. This was a provided default constructor because we can see it starts with lamp, no arguments, and I have nothing in it. Actually my constructor is doing nothing, but it is constructing our class at least. And of course, if this one is not provided, then this implicit constructor will be called, which is exactly the same. Only the difference is implicit means we are not providing it. Explicit means the programmer is providing it. Implicit means we are not providing it, so the compiler is providing it for us. And of course, we have learned also here a little bit about other constructors, for example non-default constructor, which means the difference was, again, the non-default constructors have parameters with not all default values. They can have default values, but if all of these parameters have default values, then it is considered as a default constructor. Careful about this. And then we learned also this initializer in our last video, right? This was this direct initialization. Instead of using this body, we said, okay, we don't want to use this body here. Of course we can perform it here as well, but we want use this version now, because in future we need this version here for other things. That's why we are learning this version, but no worry, you can even initialize all your variables at this point also here in this body. But you should learn this one. And here was one thing which I have forgotten to tell you in the last one. Let's do this fast too. That was the second one here, right? This class identifier brace init list. It is the same thing like here, almost the same. But instead of using this round brackets here, we are using braced brackets. We know this braced init list, right? We have already talked a little bit about it, not in detail, of course, just overflowed it. But in short, I can replace, you can see I have here a non-default constructor, but it is a constructor. We can see it starts with lamp, which is our class name. This is all time indicator for constructor, has no return type. And we have this strange form here, which can be also in one line, must be not here. I could make this in one line as well. But if the names get big, that's why I put it line by line and comma separated. And like I said, the only difference about this kind of stuff here and this one here is, of course, there are more differences, but the main difference is as here are curly braces. So let's do this one as well. Let's change this, and you can see it should be no problem. I use, of course, you should not mix it up, but if you use it, then use the other one as well. Let's do this here, and you can see this one is now this one here, braced init list. But you can see I can still mix it up in other way. For example, the next one I use it still with round brackets. This one I used here with this one. It's working, so that's not a big deal. I hope it's just how you use the initializer. So, and now I think it's time we start our simulation. But before I start my simulation, there is one more thing. I hope you paused the video and tried it on your own, because if you say this kind of stuff, what we did so far is easy, then I hope you can simulate this little exercise what I mentioned before, and now I simulate it as well. But before I simulate it, I want to make a cleanup, because yeah, the class becomes bigger and bigger, and you see I start to scroll down more and more. That's why I hope you learned by now that a class has all time normally 3 access specifiers, but we use only those which we need. For example, you can see the protected one is not used here at all. Let's kick it out. The private one, I have used it, so I keep it. Important class had by default private, so actually this line of code I don't need to write here. So that means this one is unnecessary as well. Let's kick it out. But important rule here, if you kick this one out, you should not write it under public, which means it should be still so that it has no access specifier in front of it, or to make it sure, write it in public, private. But this one is now private, because before this one is no access specifier. Like I did here it was an access specifier public. Here it is by default private. And if you don't like this, just still write private to make it sure. At start, it's no worry, but yeah, it's not a problem. So with that said, let's clean here a little bit up, because I use only this two, and then I do here again function. I won't keep this differentiate, so I want differentiate between variables function, because I like this. But you can see here again, here private, I don't need it because it's not used. I kick it out and I make a little bit more space. That's nice. I make a little bit more space. Let's make it so. And let's see here the getter and setter. We have here public getter and setter. They should be public, by the way. So I have only public here. That's okay. Then I have here my constructors. Here are some syntax definitions. I hope you learned them by default. This default I hope you learned as well. And you can see I clean here more and more up. This is a lamp, and this is a default constructor. And we learned this default constructor actually does nothing. We can use it by default when we initialize nothing. That's also nice. Here we have again a syntax. I clean a little bit more up. And here I have a non-default constructor, and they are in public. They should be stay in public. That's perfect. And here I have another default constructor for demonstration purposes, I think. And I use not even this variable here because it has not a name. It is just for distinguishing these two constructors here, but it's okay. And because I don't use it, I could kick this one out as well, because now I'm trying to simulate I simulate a lamp, so I want only keep really things in my class which I really want to use, and I think this kind of stuff we can use. All right, so it is a little bit cleaned up. It's a little bit better than before, but you see the class gets still bigger and bigger, and there is so much to talk about still, and I have only 1, 2, 3 variables. Actually, not much. And a class can have over 500. That's interesting. And like I said, in future, if you analyze a class, just concentrate on the parts which you need. There are many other parts which you probably don't need. Then you can just create a new class, copy the things which you need to your new class, or you can just use the class and use only the things which you need in the class, like we did all time with strings, for example. And yeah, now enough talk. Now it's time to create. I hope you finished this exercise. And yeah, it's time for me to show how I do. And like I said, there are different kind of solutions. And there are different kind of solution. There is not a one perfect solution. If you found anything which is which works, important is, did you found anything which is working, right? Then that's a good sign. If it's not working, no worry, try to solve it. That's also a very good sign, because if you try to solve it in future, one part of a program is all time to fix bugs, if you want or not. And if you have more and more train about in this kind of field, then you will solve many problems in the future, and you are more valuable, because the biggest problem in future will be bugs in programming, to fix them, find them, and so on. That's why it's all time good to train. Okay, enough talking, let's get started. So I said I simulate a lamp, but the lamp class I provided, yes, that's enough for me now. And you can see here I have a bool lamp on off, and this is my state. If this one, let's put this one here down, it's irritating me a little bit, because the order is all time public, protected, private. I put it here. So you can see we have here this lamp on, off. Here is the state. When I watch the lamp, I can see with this variable if the lamp is on, off. That's okay, that I need. The lamp name, actually, I don't need really. Voltage, I don't need really for this simulation. You can see I have here two variables which I don't need, but I still keep it. But like I said, I need only this one. And let's see what I need else in this this class here, right? I need this lamp turned on, off. Yes, because this function here, this lamp turned on, off, when I read this, is just a function which will set this here, this variable, on to true or false, which means when I watch this variable here, is the lamp turned on when I watch it. If it says false, it is turned off. If it says it's turned on, it's turned on. And this lamp here, this function here, is the setter. And this function is very important. Why? Because when I create a switch now, this switch must turn anyhow, this must use anyhow this function later. Depends on the switch, right? Because when I put the switch is turning on or off, then okay, I need this function. So I need this one, I need this one. Cool. Do I need this here, this public getter and setter? I need probably not lamp on, off. Let me see this one. Lamp on, off is now private. And yes, I need, because I want see later the state of the lamp is on, off. Because the lamp, when I watch the lamp, I want check. Like I said, I want simulate that when I watch the lamp, I realize the lamp is on. And in programming, it means simulating this one is when I watch this variable here, it says if it's turned on, off, and I need this getter here to print out a message where it says, yes, lamp is on, off. Depends on this variable, because this variable itself is just a bool. But to use this bool, I can write a message, depends on the bool, if the lamp is on, off. So this I need as well. But I mean this, not the setter, but the getter I need, I think. I need the getter, because here I write this message, but the setter I don't need, because let's watch it again. Because when I use this function here, lamp turned on, off, bool switch, I want that this one is setting this one, right? So I don't need actually this setter here. So I have identified my things, what I need. I need this one, I need this one, and actually I need this one. So I need only three things here. This one variable, this one function here, and this function here. And all other things I don't need. And this is just an example for future classes. They have, of course, not like me, only 7 entries or something like that. They have 500 entries, and you have to choose the one which you need. In my case, I need only this 3 here. All right. So, okay, I have this one for a use case. And of course, I have to think about a constructor. I almost forget the constructor. What happens with the constructor? Do I need this constructor here to assign values? Lamp name, actually, I don't care about this lamp name right now. Voltage, I don't use anyway, because I said before I will not use that. So not really. So with other words, I can use the default constructor. So I have the default constructor and only 3 things which I really use in this class. All right, that's interesting info. But now I need a switch class, and let's make a switch class. I hope you know how to make now a class. You learned a little bit of syntax. I make a very simple one. First of all, I start with class. I say it a switch because I want to turn on the lamp. Switch, we can call it also switch for lamp, or we make it a general name switch. Let's call it switch in general, because we can specify it later when we declare the variable name. All right, that's cool. And then I make the body, and you can see I have already created a class, but important by default private access specifier. And now I have here to think what I want to do. I want that the switch has a state. The state means situation of the switch. If it's the switch in the situation right now when I press it in on situation or in off situation. In my case, I call it just a bool, and I call it switch on off. And I assign it by default false. And the reason why I define it by default false is because your switch depends on the day. It's normally off. For example, if you leave in the morning your house, you don't need light because it's the morning. Enough sunlight comes in your flat. There is no need for light. You have enough light from the sun. But that's why we have the start false. But later you come late in the evening home, and then you want press the switch, and then you want turn it on. So okay, we have figured out this is okay. The next thing what I need is, of course, specify this class access specifier. Should it public or private? In this case, let's make it public because it's easier to access for me. Why not? And I can still later make it private if I want. So don't be very unflexible when it comes to something like that. When you specify here public and you need it later private, just change it. That's very easy. So in this case, I start with public, and then I need one more thing. So this is almost finished. Of course, I can make here also a constructor, and we can repeat constructors, but actually we can repeat constructors because we learned constructors in the last video, but I'm not sure if I need one because this lamp function needs just an info here, and this one is just bool switch the things. The only I think I need nothing right now. This is enough for my, you see, I have created a very little function class here because I literally need nothing. And if I need anything later, I will add this later. Perhaps I need, most time you need later something, or you need to add something. But at start, you can start literally with a class like this, and you will see it if you need it later. So let's see, and if you have no clue like me what to do next, is let's start the simulation. So, well, I think, yeah, I have all what I need. It's not true, there are some kinds of, there are parts missing, but I have no clue how to go on. So I start the simulation, and where I start the simulation now, like I said before, the simulation you start here in int main, because the program, the procedures will be called, and all what you simulate, you can here step by step doing, yeah, you can do all step by step what we did in our tutorial so far, right? You can call it and then it will do this one. Then you call the next step and it will do this one. So the first thing what I want is, I work with these two classes. I need two class objects, which means, with other words, in our case, we need two variables which has access to these classes, right? So let's create two variables for these classes. One is, again, how we create these classes again. Important, if it's in a namespace, you need the namespace name as well. Let's copy this one. Let's put it here. And this is a namespace name. I need one variable name for my lamp, and this lamp name, I call it now. This lamp is very general class, right? That's why it's called lamp. That can be anything. And now you have to choose a better name. In my case, it is Coder's lamp. It is Coder's is, let's say, my name, and this is my lamp. And I have already here a problem. No default constructor exists in the class. Okay, I have no default constructor. I have to define a default constructor, it says here. Let's do it. And like I said, I need only a default constructor. And how I make a default constructor again? What was the rule? Just fast lamp name, round brackets, and this one here. And of course, when I would make this a little bit more. And of course, it should be in the access specifier public. And now, which I kicked out before, I have bring back. And important is here why it was asking for a default constructor. I mean, in my last video, I made there an example where it was not asking for a default constructor. Why it was asking now for a default constructor? What is the difference between that what I did in my last video and in this video? The difference is if you have, let me show you this one, if I can do this. Yeah, I think I can. If you have nothing in it, Control X, I make this one so, save, then you see this one is not asking for a default constructor. That was the difference here. You can see no problem. There is no problem. But the difference was, and now we are back. The difference was here, I provided, and I think I forgot to mention this one, I provided here a non-default constructor. And if you have a non-default constructor, the compiler is assuming if you are not providing a default constructor like this one, like so, the compiler is assuming you are only allowing to create variables or objects only with this constructor here. With other words, I have now to use this constructor if you are not providing a default constructor, which means I have now to find here a name, for example, coder. And here I have to write a double value, for example, 5.5. And now this is allowed because now you say to this class, you have to use this kind of stuff. I think I forget to mention this one, but okay. But in this case, I don't need it, which means I have to, because I don't provide anything, it's too much work. I provide a default constructor, which is doing nothing. So I provide this one here. All right, with that said, I have created my first coder's lamp, that is this lamp class here. And now I need to create the switch class as well. And let's create this one as well. So now electrician again, and you can see here one more thing. Here are symbols, at least in if you are using Visual Studio. If you are using any other IDE, they have also some interesting things. And this symbol is already indicating that it is a namespace. And if this is not clear, don't worry, there is also this tooltip. All time try to read also this tooltip from now on, because that becomes more and more important, especially for starters, and it gives us many informations. But okay, enough for that. Let's continue. Electrician, and then you can see here the next tooltip. It's also very interesting. You can see this electrician namespace has two classes here, and this symbol is a class, this symbol is a class. Again, try to read this tooltip. It's very little. I don't know if you see it. It says here class. Yes, this one is a class. It's in the namespace electrician, and we have a class lamp in it. Okay, try to understand this one, because this tooltips will become very, very complicated in the future when we go a little bit deeper in it. And that's why it's very nice that you start to understand it when it's still easy. All right, so with that said, very cool. And let's create here, oh, not lamp. I already created a lamp object. I need not a second. Of course, I could create another, but I want a switch this time. All right, and I call this coder switch, because now it's the switch of mine. And you can see here I used few times the default constructor, which means here the default constructor. We go to my switch, and here it has not complained, right? And the reason why it has not complained, I showed you before. If there is no constructor provided, then the compiler is providing an implicit constructor. But if you provide one, then the compiler says you have to use this one, or you provide default constructor explicit. So, and I said before, implicit means all time the compiler is doing something for you, and explicit means all time the programmer has to do, right? Something like that. All right, with that we can go on our simulation. Okay, I have now created the simulation, the objects which I want to simulate. There is actually one more object, but I skipped this object. That would be the person, the coder itself. For example, I have to create now a person class, which is me, who's entering the room, who's turning on the switch. Oh, but this is a little bit too complicated now for this little example. We switched it. So we are using just these two objects for our simulation. And that's why I just use here this coder's name here all the time. We know the person is coder, so we don't make here a class person now where we assign coder in it and so on. We can of course blow up this example very high, but we try to make it very simple. But let's continue. Now I have the objects which I want to simulate. It's nice. What is the next step? The next step is, first of all, let's start with the simulation. Also, let's call here simulation start. And let's call here this one here perhaps simulation objects. Objects to use, right? Something like so. Simulation objects to use. This simulation objects I want to use, and here I start my let's make this so. Here I start my simulation. So the next step is now how I start this. First of all, I said I'm the coder, right? I go into my room, and the first thing what I notice is the state of my lamp. And the state I said is, state means in this case that's just the situation. Is the lamp turned on and off? And this behavior that I see it means in coding that you are just asking for this variable lamp on off, if this is on or off. This is just, that means simulated. So I simulated when I enter my room, if the lamp is on off. In coding, I ask for this variable and I turn for example, I print out this message if this is on. How we can make this now? This is my first step. And like I did, it is, we are using here the lamp, which means I already created here a variable for lamp. That means I just need now get this lamp. Where is this state here? This bool lamp off, but careful, it is private. I can't call it, which means, what means this again? Which means if I enter here coder's lamp, which is my variable name, which I want to use, like I said, we use all time variables, then I use the dot specifier. And you can see I have here options, but these options here are only public available options. And the problem here is this is private. If this would be now in public, I could just call it directly without any problem. But in this case, I put it whatever, why, I don't know why, in private, but it's good for exercise purposes. So what I have to do now is to get the still, because this one is telling me the state, the situation of the lamp. And we learned there is something like a getter and setter. Yes, because this getter and setter has the function to get private variables. And this getter here, lamp on off, in my case, is returning lamp on off. It's this private variable. So I need to call this one, and I get this, so I have my state. So which means if I enter the room, I need just to call what? The function. Let's do it. Lamp, which was it? Getter, it was something lamp on of getter. Yeah, here is the getter. And important here, one more thing. All time when you hover your mouse over it, try to read and learn this one here. Like I said, in future, this one becomes more and more complicated. So when I hover my mouse over this function, it says this function here, member function actually called here, bool is my return value. It is in my namespace electrician. It is in the class lamp, and I am using this getter lamp function, and we can see it is a function. When you see here, it's very small, this round brackets at the end, and a little bit also this color indicating, which is also nice. All right, so I calling this getter lamp, and the nice thing is I can see also I don't need anything, no parameters, because that's also very nice. So I can stop here, and just by calling this one, I get what? Before I scroll it up, what I get it? You can check it here again. I get a bool, but a bool is cool, but for my simulation purposes, not enough, because it says true or false. So I need one more step, which means for my simulation steps, I need to print out a message. For example, the lamp is turned off or on, depends on this return type here. So how we can make this? How we can make this? We did it like all the time with our if condition. I hope you have not forgotten how we make if conditions. Joking. No, of course you know it. So I check this if, because, and I know this one is just returning a bool, and this one here on top is just my variable object. So don't get irritated by this one. This one is just the object. This one is the function, and this function will return a bool. That's very important here. So if this one, so this whole thing here has a bool value. That's very important. That's why I can use it in a if comparison statement. I say if this one is true, right? And now I'm simulating. If this is true, then I know, oh, lamp is on. Okay. You can print out as it is, say out, lamp is on. Lamp is on. Just let's make it simple, right? Let's make it not too complicated here. Else, and we know if that's not true, then the else statement is automatically true, right? And we can print out, again, this kind of stuff, but with off, right? So, off. Lamp is off. That is the thing what I realize when I enter my room. Let's write here, for example, I comment entering room, realizing if lamp is on or off. So that's my first simulation point. The next thing is if it's dark, I want to turn on the lamp. So, and let's say it is dark. Let's say this is a requirement. It is dark. It is dark. I want to turn on the lamp. It is dark. I want to turn on the lamp. So what I have to do now here in the next step is say, okay, the lamp is on. So I go to my class, and how I can turn on the lamp now. Right, so the lamp is here. The state means here the situation of the lamp is right now off. I have asked this function here, but let's start here before I go on and finish here. Let's test this code like I forgot here, and you can see right now lamp is off. So that's a good sign, because all things what we did so far is working. So we created here this variable, so I asked here, and right now it is off, and now I'm in the simulation step where I want to turn it on. And how I can turn it on again? So yeah, now you have to go again to the class, analyze it a little bit and say, okay, this class has, this is the state. And now I need something who is manipulating the state. And we figured out we have here a function which is actually changing the state. But of course, this function has also its requirements. But I need to call this function here. That's a good sign. And then I can change this state, but this function is asking for a switch, right? Is asking for a switch turn on param. All right, so we have to get here anyhow the switch on param. But before we get this one, let's make it easy. Let's just call this function and then we see what we need. So we go down here. I say, okay, I want to turn on the lamp. So what I do is my coder's lamp, because this is my variable name, this is my lamp. And now I say here, there is this one function which is turning a lamp turn to on off setter. No, it's not a setter. I need this lamp here. And again, hover your mouse over it and then read what is doing this one. This function here is a void function, which means no return type. No return type means most time you have to watch this function body, which means the definition to understand it most time. And then here you can see it is defined in electrician, in lamp, and it's a function, and it needs here a bool switch on. So with other words, it needs here a bool, and this bool is indicated in my case that it comes from a switch, right? I have wrote here already switch turn on param. So I already indicated here from the where I want this variable. This is not very important because variable names, you can name it like you want. Important is that it must be a bool. In my case, okay, let's make here something. And the problem is now, okay, I need a switch here, bool. How I get the switch here? Actually, we have here a switch variable, so that's nice. And the next nice thing is here it is public and it has here a state. Okay, but here is a problem. The state here, it said this is for it is switch on off, it's false, so it is false, which means it is turned off. I won't turn it on. So anything is missing, right? Like I said before, this switch class is probably not thing, and I already made here some little bit pre-work, so I don't need to write a little bit too much. And then I just copy this line because it takes too much time if I make all by one. Let's copy this one here. And I put it in. And what I'm putting in now here in my class is a functionality which I have made already before. And like I said, I need a functionality. I have not a functionality. And now I have another problem because I added here, this one is a variable, and what we learned, we should all time distinguish them a little bit, right? When we create a class, let's write here variable, and let's write here functions, so we have no problems later to find them. It's very easier, so I put all the time variables on top, variable functions here, and I created here this void using switch function because I want to use the switch. I have only a state of the switch, which means just the situation of the switch, but I need a way to change the state, which means, and if you need a way, which means an action, you need most time a function. And in this case, I created now this function here, void using switch. And when I call this switch using, I just check this switch on off variable here. If it's false, then I will turn it to make it true, because then because this function using switch means I'm putting my finger on the switch. That is the meaning of using switch, my finger on the switch, and then the switch performs an action, and now it turns on the switch and turns off the switch, and I use this later in my simulation input for the lamp. So that's a good thing, and I made it again public. That's also nice, because I made a public means all time easy accessible instead of private. So, all right, that's enough for this switch. Let's go to my simulation, but here is one problem, right? What is the problem? Like I said, I'm right now in the class switch. I'm putting my finger on the switch. I'm not in lamp now. I'm in switch, which means I should perform an action on switch, and performing an action on switch means I should use the switch variable and then call this switch function before, because this one is changing the state of this variable here. Let's do this one, which means before I can do this function here, what I want normally, I need performing the switch, turning on the switch. So I want go to my switch. Here is coda switch variable. This is my object. Object means just a variable where I can access the class. And now I can use the function because I put my finger on the switch and I using switch. Then here is the function. And again, here you hover over it. And we need, of course, the function. And here you can all time see if you need parameters. In this case, I need, again, no parameters. I made it very simple. And here at this point, I use the switch now. And after I use the switch, and the switch I made the program so that all time it is the opposite when I use it. For example, if I use it first time, then it checks if it's false, then it makes it true. And if I use it again, then it was true and it makes false. So it's like a flip-flop, if you know what it means. It means just all time when you put it, it's the opposite will come out. Yeah, that's not too difficult. So you can go on the switch. You can see if you put one time and put your finger on the switch, it is on. And next time when you go again to the switch again, it was on, and you press it, then you make it off. It is all time flipping to the next state, right? And this was the simulation here, what I did here with this little if setup here. Very simple. I hope you understand this little program by now. It's not difficult. All right, we go on. First of all, I use the switch. Also here, let's go to our simulation back. It says here, it is dark, I won't turn on the lamp. I am using the switch. All right. I am using the switch. Here I use the switch. And after I use the switch, here I changed only the switch state, which means this one will be true now. Then, after the switch state is true, the interesting is I'm not interested in the switch state. I need this to turn off because I'm interested in the lamp state. The lamp state here is this here. I'm interested in this value here actually. The problem was before, this value is dependent on the function which says turn lamp turn on off, and this one needs a switch. Cool. All right. Which means now I can call this one here because I have now turned it off. But oops, what I did here. But here is another problem. So how I get the switch class here anyhow in this class? Or do I need it? Is the question. Perhaps I don't need that. Well, because it can be irritating. You say, hey, I try to call this one here, but I have in this class no switch class. But actually, perhaps I don't need it because I have here the coder's lamp, which is here defined. And here in this area, in this function here of main, where I simulated, I already have a switch now. Here, which means actually in this class lamp, I don't need a switch, right? And that's nice, which means I can call now here this lamp turn on off here at this point with, how I call it now? You are going to coder's switch, because we have created this variable here. And after this situation, it is changed, right? I know it is changed after this one because I put my finger on it. And now I go here and switch on off state because this is the variable which I'm interested in. Here, this is this variable. Let's go here. This is the variable. It's public. That's why I have access. Very important. It's public. It's not private. If it would be private, then I need a getter or setter, something like that. Oh, like in this lamp here. That's nice because it's public in this case, which is good. So with this line of code, I get the state of the of the lamp, right? That was here. Where is this again? Here, lamp turned off. And now I change here the lamp state. So, and here we write here one more comment because it's a simulation. Here I'm using the switch state. State means again situation, right? The switch state will determine the state of the lamp, right? So the switch state will yes, the switch state will be used to change my lamp state, because I have also here an action. The action of the lamp here, you can see, is dependent on the switch here, which I get here, and here I am. So I hope it makes sense. If it's not perfect, doesn't matter. It's just a prototype. A prototype means old time. It can be wrong like hell, and you have to polish it later anyway. All right, let's go to the next step. So I have changed this one. Of course, you should test your program if it's working. So let's test it. Perhaps there are some errors. I see nothing actually. I see the lamp is off. Of course, I see nothing because I have nothing printed out here. So you can make some print out checks. For example, if you are not sure, like you can see here, Coder is switching lamp. Okay, now print out the state of this lamp. No, of the switch here in this case. Okay, let's make this a print out check. Is just here. Let's make here something like lamp. No, switch. Switch state, and then we can make something like so. I check this, coder switch again, and paste in, and then ask for the here of this one. This is oh no, this is a bool again. If it's a bool, switch on off, then of course you can't use just here this print out normally. Then I need again something like so, or there is a ternary operator. I could use this one as well, but I'm too lazy. I skip this kind of stuff. You can make here a check if this is turned on and turned off, right? You know what I mean. You just write here and then print it out here anyway with a ternary operator, or like this one with a if operator, or what you want. Yeah, different options. But I skip now this one and go on. I know it will work. I assume it will work. Don't normally you should be not so sure. Most time if you say I know it will work, it will definitely not work. That is all time an indication. You should all time check. So I hope it worked. Let's say so. All right. The next thing is what we have to do is okay, the switch state is now simulated to turn what I did here. I have here the turned off the switch state, so the lamp here. Actually, this is the lamp doing inside, and now it is turned on. And this one I want print out, because now I see after this comment here, I see now that the lamp should be on, right? The lamp its own will make light now. So I want to see if the lamp state is indeed on, and this one we are printing out. And I'm again too lazy, but here interesting, you see here on top what we have. We can just copy this one here, because here I was entering the room, here I was using the switch, here the switch changed its states dependent the lamp changed its states dependent on the switch, and now the result is that I can see light. And let's write here the last simulation step, which is just, let's write here coder can see light or not depends. we can see it because here is my result. So, and if I start this, all right, I can see light. I have indeed turned on the light which was on. And you can see here, this was a little bit simulating, oops, not this one. This one was a little bit simulating a class and the use of a class, right? Very simple class. It's absolutely one of the simplest class. This one is even more simple. There I added here just one bool and one functionality. And you can see here is the simulation part. Well, here we simulated how I entered the room. I saw that the light is dark, so I used the switch, and then the switch turned on, changed its state first, and the changing state changed the lamp state, and the lamp turned on the light, and I could see light. That was so the simulation part. And I think that's enough for this one, because I thought it's very nice that we repeat this kind of exercises too, and make this kind of stuff. And here I introduced another thing, second class. And there is one more thing, perhaps I should say, when you have here a class introduced. Oh no, we talk about this in the next video, I think. And you want to use this class here and the other class here, then there are some special rules to consider. And this kind of stuff we talk in the next video. Normally I wanted to make it here too, but I skipped this part, I think. All right. Anyway, I hope you made also a simulation of a class, and like I said at the beginning of this video, you can see this class understanding what we did so far is not very difficult, the class itself. It's very simple. But to use it now here in a simulation environment, what I did here, it is also not very good, but at least it is a beginning. I hope you did something similar. And even if it is simple, later it becomes more and more and more complicated, because in classes there is so much to talk. And that's why I made this one here now, this practical exercise. Not that you get overwhelmed later, so that you get a little bit used to these classes in a practical way, so that you really can use them and not just understand them later. Like I said, all the time there are people who can understand all the keywords which we discussed till now in less than 1 month. But if you ask these people if they can program also now after they understand all the keywords, nobody can program. They need still 1 year. And the reason for that is they need to learn programming by using and seeing stuff like this one. This 2 classes which I used here was very simple, and still the simulation was still for beginners definitely challenging. Of course for advanced people not so, but for beginners this kind of little code was already challenging. There is so much input already, how you call it, what you have to consider and when to consider, what you have to do. And I hope you made also tried it a little bit and saw that yes, it is not too difficult right now, but it is still work and we have to practice, exercise it. Yeah, and with that said, I think I stop this video here. And in the next video, we will continue with our classes. There are many things to discuss. And if you have any questions or any complaints, like all-time tips and tricks, write them in the comments so other people can see it too. And with that said, bye, good luck, and like all time, don't give up and have fun.